Hey you guys, I'm back. We're moving on to rational numbers now. This is pretty key. They want you guys to know on iStep what rational numbers are. Basically anything that we've talked about, integers, whole numbers, those are all rational numbers because they are numbers that can be written as a fraction. So any number that can be written as a fraction, well, you know when you divide fractions, you either get a terminating decimal or a repeating decimal. So those are also called rational numbers. The only kinds of numbers that we haven't talked about are irrational numbers. For example, pi. Pi is irrational because it goes on forever and never terminates and it never repeats. So we are talking strictly about rational numbers. So it says show that the number right here, show example 1, is rational by writing it as a quotient of two integers. That means write it as a fraction. So A, that would be 3 over 1. B would be negative 12 over 1. You could also write that as 12 over negative 1, or you could have a negative and then 12 over 1. 4 2/3, just make it as an improper fraction. So that would be what? Multiply and add, and you get 14 over 3. This one, just leave the negative out in front and do your multiply and add, and you get negative 9 over 4. We have some fractions that are common fractions that we should know off the top of our heads, but problems like the A, write 5/16 as a decimal. Well, when it's as a fraction, you just divide. So when you divide that, the numerator goes underneath, divide by the denominator, and you get 0.3125. 4/9, all of the ninths are the same. When you divide them, you get 0.444, so it's 0.4 repeating. These are rational numbers because they're written as fractions. 1/9 would be 0.1 repeating. 2/9 is 0.2 repeating, and it keeps going on like that. All the common fractions that you should know, the halves, thirds, fourths, fifths, eighths, and tenths. You should know all of those and be prepared for a quiz over that. But what about some of these problems that are a little bit easier? For example, 7 over 20, it says write the fraction as a mixed number or mixed number as a decimal. We can make this out of 100 simply by multiplying by 5 on the top and the bottom, and we get 35 over 100. That is read 35 hundredths. So you don't even need to divide on that one, but you can. Do 2, 3, and 4 for me. Now, we're going to compare two fractions. Okay? You can either reduce them, or you can change them into decimals. Okay, so 42 over 48. That reduces to, let's see, what goes into both of those? Well, if you're one that just likes to chip away at it, you can say, what, 2 goes into each of them? That's 21 over 24, which 3 comes out of those, that's 7/8. 27 over 30, that reduces by 3, and you get 9 over 10. So basically we're comparing 7/8 to 9/10. Okay, so once you have 7/8 and 9/10, you can put them as decimals. This is 0.875. This is 0.9, and therefore this one is less than. Okay, writing terminating decimals as fractions. Read this the way it's written mathematically. It's 3 hundredths, so we're going to write 3 over 100 and reduce. Negative 9.4, that's negative 9 and 4/10, so we write negative 9 and 4 over 10, and reduce, and you get negative 9 and 2/5. Okay? All right. right, now what happens if we have a fraction or a decimal that's repeating, 0.81? What we're going to do is we're going to let x equal 0.818181 dot dot dot. And you notice in this problem, okay, so by letting x equal 0.8181 dot dot dot, when we need to move this over 2 places, that's multiplying by 100. So I'm going to multiply this whole thing by 100, and that gives me 100x equals 81.818181, keeps going, right? So what I'm going to do is I'm going to subtract the x from above and what it's equal to. And when we subtract that, 100x minus x is 99x, equals, what happens on this right-hand side is the decimal points cancel off, and we're left with 81. Now this is just solving. Divide both sides by 99, and reduce this fraction. So 81 over 99, 9 goes into both of them, so we get 9 over 11. And you can check it on a calculator. So if you had something like 0.7 repeating, you would let x equals 0.7777 dot dot dot. Since you want it to move over one place, you'd multiply by 10. You'd have 10x equals 7.777. When you subtract that x off of there, you get 9x equals 7 divided by 9, and the fraction would be 7/9. It just depends on how many places you have to have it move in order to determine if you're going to multiply by 10, 100, 1,000, whatever. You guys go ahead and do 5, 6, 7, and 8, and bring those back with you. Alright, the last thing we're going to do is arrange these numbers on a number line from least to greatest. And what we need to do is put them all in the same form. Okay, so negative 17 over 2, that is when you divide negative 8.5. Okay, so I'm going to go over here to negative 8.5 and put that there and write negative 17 over 2. Negative 1.35 is a little bit past, which is about right here. That's negative 1.35. 5.67 is on the, hang on a second, I thought this was going by ones. It's wrong. It goes right here. 5.67, a little bit before the 6. Negative 6 is back here. 11 over 3, when you divide, you get 3 2/3, which is almost to 4. So there's 11 over 3. And negative 13 over 4, when you divide 4 into 13, that goes negative 3 1/4, which is a little bit past the 3, so that's negative 13 over 4. And all you have to do is list them in the order that they are. So it's negative 17 over 2, negative 6, negative 13 over 4, negative 1.35, 11 over 3, and 5.67. Okay? Bring those problems back with you in class and let me know what you think. Okay? 1040, over and out.